Well, thanks for having me. I'm excited to be here. So, and until it's my first time in Liverpool, so here we go. So yeah, today I'm going to talk about one project that we're working on now, as the title says, that tries to develop a large language model to classify contrarian claims in climate discourse in the U.S. Congress. So I was telling Ansel before this isn't like, it's a little bit raw, actually. So yeah, half of it's really polished and the other half's not really polished, but I'm really excited to get feedback on the non-polished bits. And so, yeah, anything you guys have or any perspectives you want to bring, great. I've also been like giving presentations, I feel like in a bubble lately. It's like only to other computer people and computational social scientists. So definitely feel free to interrupt me at any point. Like, I don't mind. I know Ansel will probably, like, if the past predicts the future. No, but yeah, really, I don't mind at all. So just interrupt if there's anything that's unclear. But yeah, without further ado, we'll get into it. So let's see. How do that works? Okay, yeah. So just a little bit of motivation. No, yeah, okay, we're good. So yeah, so lots of research to suggest that climate misinformation has the leadership effects. Okay, so like I won't belabor that point, but I think there's enough scholarship now to suggest that it does quite a few negative things. So that's kind of the backdrop to all of my research is that. But this project is very much directing the focus at Congress and why Congress. So contrarian voices, and I'll use contrarian, skeptic, I'll use that all kind of as synonyms, but folks that don't buy that there's a scientific consensus on climate change, don't think we should do anything about it. Those folks permeate government, right? And especially in the US, right? So all the way up to the very top with Donald Trump. But in the US Congress, this has been going on for a long, long time, okay? And particularly the US Senate has been, I mean, we'll talk about like a veto player blocking not just US climate policy, but really international climate policy. Yeah, so even starting at Kyoto. It's very difficult to get an agreement if the sort of leading country at the time that's kind of shifted a little bit in more recent years isn't ready to play ball, okay? So these 100 people have a lot, 100 plus one, if you consider the vice president, has a lot of influence on not just domestic climate policy, but global climate policy. So something that we think that's interesting to sort of shine a light on, okay? Where we're coming at this is really from the perspective of trying to figure out what the discourse looks like. So what sort of claims do we see in congressional speech, okay? And so for us, we're really interested in very specific claims, okay? And that comes out of some work that I do with colleagues that are psychologists that want to craft debunkings or pre-bunkings to respond to this sort of misinformation. And they've kind of repeatedly tell us that we need very specific forms of misinformation or contrarian claims. So we're really coming at it from that. So we really need to get this sort of specific, these specific claims. We don't have that as far as I know. There isn't a lot of good research on specific sort of contrarian claims that show up in congressional speech. Okay, so that's kind of going, and I can talk about why it's really important to understand specific claims, and we can come back to that. But there's all sorts of reasons that we would want to know more about that. So that's kind of where we're coming at with this project. So there's two objectives that we have, and they kind of happened in parallel. They're not. So really, we started off with objective one, which is really to develop a computational model that can classify these very specific claims. Okay, so that was kind of objective one, and I'll talk a lot about that today because that's kind of where we've been spending most of our time, is trying to get this model right. And I'll talk about that much more. But the second part is really the congressional bit. It's like once we have this model, and I'll show you it and show you how it kind of works, not just for congressional speech, but once we have this model, we don't want to model for modeling's sake. We want to shine the light at something. And so that's really going into the second part of this particular project, which is really to deploy a model to look at congressional speech. So we really want to know what are the key claims driving obstruction in Congress. To what extent does misinformation appear? And not everything I talk about in terms of claims or contrarian claims is misinformation. Some of it is, some of it isn't. And what are the main drivers of these claims? So what's responsible for predicting them? And so that's really kind of the two objectives. Good. So far, yeah. So far, so good. So let's start with one. So building this model, okay? And this, we build right off of a paper that we published a while ago now, I guess it's 2021, I think, on what we call the CARDS taxonomy. And so CARDS stands for computer-assisted recognition of denial and skepticism. I can't like say that 5 times. I joke that I think it was CATS for a while, and then we had to have something that works, but that's what we ended on. But so the CARDS, actually, we started this, I think probably when Antel and I met, we started like this project in 2015. So it was myself, John Cook, who is he's the 97% consensus guy. So he's one of the ones that kind of came up with that whole idea along with Naomi Oreskes. He manages skeptical science. So he's been doing lots of stuff in this space. But him, Constantine Boussalis, who's at Trinity College Dublin, we sat down and thought, okay, we really need to get together and just figure out a way that we can start tracking the claims that are coming up. And again, John's whole drive was really to do so in a way that we can respond to. And so we said, okay, we need to get this. So we started off in earnest, it's back in 2015, like the grass is greener, like UK is still in Europe, Trump's still like, just a TV celebrity, everything was okay. We had high hopes, right? So we basically went into this thinking, okay, we'll start by developing this detailed taxonomy of climate change contrarianism writ large. And that hadn't existed, okay? Turns out like it was really, really hard. And so that's kind of part of the reason why we started in 2015 and the paper came out in 2021, okay? Because it turned out to be really, really hard. And what we did is we read thousands and thousands of paragraphs, tried to put these claims into some sort of logical taxonomy, but you realize very quickly it's not logical, a lot of it, right? Right? And there's dog whistling, and there's innuendo, and there's look over here sort of stuff. So it was actually really, really challenging. And so we'll talk a bit more on that as well. So when we built this taxonomy, we thought, okay, yeah, all right, we're feeling pretty good about this. So then it came our part, right? We needed to develop a model to actually be able to classify these things in using tweets or using YouTube transcripts or Instagram posts or whatever it may be, right? So what did we do? Well, we set out annotating a huge corpus of documents along this taxonomy. And so we actually ended up, I think there was a team from Skeptical Science, which is John's sort of people. They annotated like close to 80,000 paragraphs, 30,000 of which of them have a hit along this taxonomy. That's a massive amount of data, right, to annotate. But we had to do it because we wanted to be specific, and it's a humongous taxonomy, as you'll see. So that was really, really difficult. So got through with that, then we applied the model, and we thought, worked okay, and we thought, okay, yeah, we're good, we're done, right? We've done it, like we're gonna celebrate. Turns out like it didn't work quite as well as we thought, right? So it works very well in the context in which we designed the model, and we designed it for a very specific purpose, to monitor contrarian claims within a set of known contrarians. And that's really what we set out to do. We know these people spread various forms, various claims, various types of misinformation, whether it be in Congress, the news. We want to monitor those people. Works very well on those people. But as soon as we left, as soon as we publish the paper, we put it out in the wild, everybody wants to use it for their purposes, right? And they don't want to use it for this very narrow set. They want to just be able to apply it to anything. So we already started to realize, okay, it's difficult. Now, I'll come back to that a little bit. But before I get too far down so when I say taxonomy and I say specific claims, this is kind of what I mean. Okay, and so this is from the original paper. We've changed this a bit now, which I'll kind of go through a little bit, hopefully to improve it. And this is kind of like the first thing people hated as soon as we published the paper, because it's really hard, right? Like we come up with a taxonomy, we spread it around, we have people comment on it, and then somebody else goes, but no, I wouldn't have done it like that, right? So this was kind of an initial shot across the bow for what might be a taxonomy that we could use. And we really have now, a lot of our research is trying to change this and tweak it and make it more useful for people that we work with. But this is basically what we're looking at, right? So we went through, read a bunch, found that there's kind of 5 main climate disbeliefs, we were calling them, that mirror climate beliefs. Okay, so this is it's not happening, right? So that's literally it's not happening. Sea levels are not rising. Extreme weather is not increasing due to climate change, right? All those things. It's not us, so it's natural variation, right? It's volcanoes. It's this. It's that, right? It won't be that bad, or we can adapt. So this is often the plant's CO2 is green, plant food. Why should we be concerned? And so those kind of 3 are like real classic forms of science misinformation when it comes to climate change, right? So, and all of these even subclaims have been debunked in one way, shape, or form. So those are solid kind of forms of misinformation. Okay. The 4th one is that solutions won't work. And this is where it gets murky, right? So in our solutions won't work category, we have policies are harmful, policies are not needed, right? It's too hard. So we have these various sort of claims that show up, and not all of those are misinformation. It will be costly. Does it mean that we shouldn't do anything? No. So this is definitely where we're venturing in from what we would call discourses of maybe denial to discourses of delay, right? In the Will Lamb et al. Sort of setup. Okay, so we have the delay sort of claims, and then we have a 5th set of beliefs where that's basically climate science. Proponents of climate change really can't be trusted. So that's either that the science is unreliable, or what's becoming much more common is sort of ad hominem attacks on scientists, on anybody that's a proponent, right? So this is, you're an alarmist, you're corrupt, right? So these are the sorts of things we're trying to get at, okay? But again, like I said, like once we came out with the model, we put it out there and people started using it. They were really like pumped up to use this model. As soon as you give somebody a model that they think they can hit go on and work, right? That's the first thing they do. And yeah, we got some feedback, right? So the taxonomy, definitely not perfect. Is that good? Yeah, okay, great. Taxonomy, definitely not perfect, so needs to be improved, right? And so unfortunately, not only is the taxonomy not perfect, it's not perfect particularly for solutions won't work, which it turns out for Congress is like the dominant claim. Okay. So we had to sort that out, and we started to work through some of the ways in which we can kind of improve that. Challenge 2, this is where it starts to get a little bit techie, but like the model, it turns out that it doesn't generalize well. It did really well on the paragraphs that we were looking at, but once we went out to tweets, once we went out to Instagram posts, they're very, very dense with the sort of information that's in them, right? So you can have lots of different claims in a single tiny little tweet, right? So very, very dense. And so we needed a model that could work better for those sorts of texts, right? So it's not multi-class in our language, so a single class per paragraph, but it's multi-label, something that can have multiple, and then challenge 3 is that people really, they wanted to use the model out of the box, right? I just want to use it to see if there's misinformation there, right? I don't want to say, of known sort of contrarians, these are the sorts of claims they say, right? And so this is probably the biggest one for us that we needed to solve. And in order to make this a approach useful for people that are using this on the ground. And that really was our sort. We set out to do that, right? And so, and what happens if you don't correct for this is you get lots of false positives, right? And that makes sense. So we needed to come up with a way of overcoming these sorts of things, okay? So what we've done, and it was long, sort of secure sort of routes, is we've really ended up with this LLM-based sort of model. Okay, so large language model-based, not too many model, but you know what I mean. Okay, so this and this really is, I don't know. I mean, I know everybody's on ChatGPT and everybody's following this. I've been doing natural language processing for 12 years, right? So like I've seen the whole life cycle, I think, of this from when it started, like we could do barely anything that was useful to a social scientist, all the way to now and it's really like a game changer. It really is. I can't underscore that enough. I mean, it's not perfect. The hype is the hype, but it's unbelievable what we can do with these models with so much less data, like such little data. Okay, it's unbelievable. And I'll show you kind of the pipeline that we've come up with to use these, but yeah, so lots of promise, right? But there's also challenges with moving to an LLM-based sort of approach. One is sort of cost and scalability. So it costs a lot to use sort of what we would think of as frontier models. So that would be like your GPT-4o, not really anymore, I guess. It'd be O1, O2, like from OpenAI, or Sonnet 3.5, Claude from Anthropic. Do we know these ones or no? Never heard of them? No, yeah, you guys should stop me. So these are really big models. And so you can start, these are like global benchmarks, right, for different things. But, right, so Claude 3.5, this is Anthropic's like everybody knows OpenAI, right? Okay, and so Anthropic's kind of the anti-OpenAI. It was like somebody that worked at OpenAI that went out and started another company. So some of these other models are getting out there, but you can't really use them. Claude is like one of the best general purpose. This 3.5, one of the best models in the world. Okay, will crush OpenAI's or what's up? I don't have I don't have that in here. No, but yeah. So right, but the problem, these models are like really big and really expensive to use, right? So, and we have millions of texts, right? So we want to figure out a way to make it cost not a lot, to scale, okay, and to be relatively fast, okay? So latency is always a really big problem for us. We can't just hit go and wait forever. We really need to be on real time. So these are some of the things we've started to try and fix. I'm going to switch. I know this is going to screw up Zoom, but I kind of want to show you guys the model, and then we can talk about like how we got there. And if this just is too, let's see, I'm going to try and do this. Yeah. Cool. Right. So I'll just leave it like this, I think. Yeah. Okay. So this is and I'll talk about how we developed it, even though probably nobody cares but me. But let's watch it first. So cards, and we obviously had to name it Cards B because I mean, you have to, right? And we actually looked up, will we get sued by Cardi B? Because that's actually trademarked. No. So we're good. But basically what this is it's just an interface that we actually use this to fine tune our model. So we actually use this to provide feedback and save it and give it back to the model to fine tune new instances. We use this interface for a lot of different things, but one thing we can do is use it to show you guys what's going on. So over here, we have our code book. So this is like all the things that showed up in that big bit. And so there's also, it's not happening. And then there's all the ways in which it's not happening. And so this is, but blah, 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 blah. So let's let's start with, I guess we can start with a softball. Let's see. Oh yeah, here we go. Oop. something like that. Might take a second to wake up. Sure, let's break this down step by step. Right, so it's going through and doing actually all the chain of thought processing to try and reach the correct solution. And so at the end of the day, it spits out this code, yeah, 620, right? And if we go here, oops, I can't type on this. Is that right? So climate change is a hoax or conspiracy. We've been deceived by climate scientists, right? So, and so basically all the work we had to do was effectively like get a model to think like this, like to do what we would call chain of thought reasoning, right? And we actually, if you look, the model that this is using is the R model, right, that we've created. This model is small, scalable, cheap to run, like has all those sorts of nice features, but still can do this sort of chain of thought reasoning. So that's kind of what we're working with here. What are some other ones? Like, should we try to break it? Like, what about the cow farting one? Did you guys see the, yeah.
Do you know what I mean? If that's a they are lying to us, because they is quite a spiritual.
Yeah. I mean, absolutely. The is like it will see my screwing up. Yeah, like I bet it assumes it's they. Yeah, just because I wrote the wrong thing. And I can misspell. This is actually great. I can misspell, do all kinds of things, and it really just ignores it. It's like, no, I'm smarter than you are. You clearly meant they. Yeah. So, I mean, it's pretty gnarly, right? Like, and we'll kind of talk a little bit about how we would do this. This might be something you would expect by like from a big model, from a big company. But again, the way in which we were able to do this was on the cheap. Okay, so we can kind of, yeah, show some ways. Is there another one you want to try? I can't really type on this keyboard. It probably will mess up. Yeah, this is this one. Yeah.
Than coal plants.
Oh yeah, I don't know what that I don't even know if that cow farts are more dangerous than, is it then or than? Yeah, this is that. Oh, did I?
I thought you were doing, but I'm not sure that is like. I don't know. Like
No. This is actually, yeah, methane is like.
Methane emissions, yes. Amor Harper from Commission, matched with Codeberg.
Yeah, because I don't think we really have any.
Any specific, okay. Okay.
Yeah.
Yeah, but it's fair enough, yeah.
Yeah, it's a more significant issue. He's not belonging in any of the categories. So it's pretty good. It was like, nah, dude, that doesn't. But if we were to say, what was the thing today? The one where it was like, it was basically that we're eating did you guys see the Guardian thing where it's the cow farts that we're eating? They're feeding cows this N3 or whatever that makes them exhausted, so they don't have as much methane. And there's this big conspiracy theory on it that's like causes cancer. I did try that one on the train, and it like nailed that one too. And it's never seen anything about cow farts or anything. Like it was like, but it picked up that there was health effects effectively. So yeah, I mean, we could go on and on, and I mean we could keep. Yeah, we probably don't have enough time for me to go on and on this, but that's basically the setup. Yeah, so you can see. So, and again, like you can actually, if you want to use the model, you could use the model, reach out to us. And we also have an API if you wanted to actually use it in your own research, or if you have anybody you come across that wants to use it in their own research. But enough of that. Let's go back to this, and then we'll talk about. Yeah, so how did we do this, right? Like, it seems to work, right? Okay. But how do we do it? So what we did actually is we curated a really good sample of a really good set of examples for each of the claims in our taxonomy. Okay, this is a big taxonomy, there's like 120 classes. So we got basically 5 good curated examples for each of those classes. Okay, and that took a long time to do, but it turns out that it changed everything in terms of our ability to have a model that works. Okay, we tried it in a number of different ways. Without this human input into it, like it just didn't work, which I think is really good. It made me feel good because there's a purpose for me in this world, right? So we started with that. Okay, we then had basically these combinations of inputs, which are here's the text, and outputs that we annotated, and we said, okay, this is the answer. The next bit we did is we basically sent just those for the 1778. Yeah, we sent those to one of these big models that I showed you, big expensive ones, and said, hey, model, give me the chain of thought. Give me how you would get from here to here, right? I've told you the right answer, but don't act like you don't know the right answer. Just give me the chain of thought, okay? So it goes through and it writes out all of that chain of thought, trying to connect, right, the class to the text. Once we have that, we have all these chains of thoughts for each of these 1778. We use that to then fine tune a much cheaper model, a much cheaper, smaller, more efficient model, right? So once we have this, basically we're able to almost broke the TV again. So once we have this, we're in business, right? Because we're kind of start to be able to get all the good bits of the big models with a small model, okay? So that's kind of where we're at. And then we go to our interface, we chat with it, we fix it, we say, no, you're wrong. Have you thought about this? And we can fine tune additional checkpoints on the top of that, okay? And so we do that procedure. At one point, we enter just a little bit of text on Congress, just to be like, okay, model, you've learned a lot about climate misinformation. Now I want you to learn to focus just a little bit on just Congress, what you see in Congress. So we only give 100 examples here, okay? And it's able to narrow down on Congress, fine tune again, and then we test, okay? And so that's the procedure. That's how we got to this model that we're using. And I'm going to talk about the data that we use, and I'll talk about the performance. Okay, so you can see that, and then we'll move over and just do a little bit on some of the descriptive analysis we've seen with Congress. Okay, so the data we're using both for the testing, so to check out performance, but also for the analysis in this is floor speeches. So this is just from the Congressional record. So floor speeches, I don't know how much we know about Congress, if anything, but yeah, okay, so, but yeah, you know a bit? Okay, good, Yeah, so floor speeches are obviously, they're grandstanding, right? So this is a very unique, so it's not all congressional discourse. This is a very unique type of congressional discourse. And I can come back to that and talk about that a little bit later. But yeah, so we pulled down all of these paragraphs. We ran them through another model developed by these guys, ClimateBert, to get what bits are about climate change, because we don't want to look at it all. We can't afford that. And that's basically our complete data set. So this data set goes from 94 to the end of 2023. We've actually updated it, but I haven't included it today. Okay, so that's the whole life cycle basically of climate policy in the US with floor speeches. Okay, to test the model, we annotate. Okay, just in the same way you would do it in any sort of quantitative content analysis, but we used a bunch of coders from Timmons Roberts' group at Brown. Okay, and so yeah, annotated a bunch of so about 1,200 paragraphs, and this is all sort of paragraph level. And then all disagreements from the annotation were checked by a team of the senior folks on. I should have actually, for this group, I probably should have included all of the intercoder reliability and all that stuff, but I didn't. So we can come back to that. Turns out it's not very good with the students. It's not very good at all, right? Which is why we have to do a lot of this, all disagreements being checked. Okay, go back to that. So that's that bit. But how does it perform, right? So this is what we did. And so I'll explain what these things mean. Okay, so this, starting at the bottom, so this GPT-4 mini, this is the small model that we fine tune, okay? So again, this model is actually fast and it's cheap. Okay, it's still closed source. It's not open source, but it's fast and cheap, okay? If we give this model just our taxonomy and say classify correctly, right? This is how well it does. It gets it right like 0.5% of the time, right? We can think about it like that. Do people know what an F1 score is? Yeah. Okay, good. All right. So we'll just think about it as kind of accuracy for now, but that's not very good. Okay, it's better than chance actually, given the size of our taxonomy, but it's not very good. Okay, so we go up to GPT-4. This is what ChatGPT currently uses, right? And we get a big, significant increase, right, in F1. This is still zero shot. We're not giving you any information. We're just saying, go and here's the taxonomy. These are the things I want you to know about it. Go and do the correct thing. It goes up to this. Sonnet, again, this is Anthropic. That's jumps way up. Like that's amazing. That's zero shot. We just provided the code book, which is just a mess, basically. It's this big thing. And we've said, don't give me the right answer. We didn't have to do anything. And it came back with an F1 score of 76. Right? That's like what? It's a first in this country. It's a C in the US. Right? We got a first, right? No, but we actually got a C. But this is where it gets interesting, right? So what about our stuff when we start to add the human knowledge to this and add that good chain of thought goodness, right? Well, now, right, this card mini base. This is without adding any information on Congress. This is a Congress test set, no information on Congress. This base already jumps up, goes from this, which it starts off, fine-tuned, goes up to this, right? So it can beat actually Sonnet, this humongous model, right, with just that 177, right? So this, yeah, very, very small amount of data, amount of input we had to give in order to beat a ginormous model, right? And then once we give it some Congress, right, just 100 examples, it starts to learn really well about, oh, that's what Congress looks like. You're not interested in all this stuff. You're interested in Congress. And so we get up to an F1 score of almost 84, and that's at level 3. That's at basically like the lowest level in our taxonomy. It's like 120 different categories you can come up with. Like that to me is shockingly good. Right? And I'm not even like tooting my own horn. Like it was not that good, right? But like, and it's not that we didn't do anything super special, right? It's just amazing, the difference. Yeah, so that, oh God, I mean, yeah, I spent all my time talking about this stuff, but let's get into like some of the actual like numbers, okay? Because once we have these predictions, right, we can start to do things with them. And so obviously the very first thing we did was just look at some descriptive data, right? And so this is on basically the prevalence of claims across effectively the whole life cycle of US climate politics. Again, floor speeches, so it's slightly different. But what does it show, right? Well, it shows, yeah, actually most of the conversation, not surprising, it's about solutions, right? Because they're talking about policy. And it's about we need fossil fuels, okay? So yeah, not hugely like, whoa, but yeah, but nevertheless, and it's often about costs, right? Solution to increase costs. And honestly, given our model, we can actually go down even lower into this. And it's really about the way in which they frame it as cost to people, right? So this isn't cost to companies. This isn't cost to just like in these floor speeches, they're very much about it's going to cost you, it's going to cost people more, right? So a lot of costs. You got to get all the way down here to get some science in the mix in floor speeches, but it's there, right? And it's also peaking at very specific times, right? Like, yeah. And this is science is unreliable. This is almost all, if you go down one step consensus. It's like, there's no consensus, there's no consensus, there's no consensus, no consensus, no consensus, right? And it's basically what we have: Kyoto, we have cap and trade, then we have Obama, right? The clean energy plan, right? And so, and you can see, I mean, other things that we can see, right? We also are getting this alarmism that's going up. So even in the context of Congress, this is something you see across all data sets. It's just becoming more and more ad hominem attacks and less about anything else. Right? I got a cool like Christmas thing going down here. I didn't even know, I didn't mean to do that. So yeah. But not, I mean, not shocking. It's kind of all, it is sort of all the stuff you see, but it's very granular. And what we can do is start to understand why specific claims are used and in what context. Okay. So that, I don't even know how I'm doing on time. Probably not very good. Here, I'll just bang through it. Yeah, sorry, I got too excited about the model and then stop with all the good stuff. So what about by party, right? So we can do that. Yeah, there's a lot of red. Not shocking, okay? This is like a Republican problem, right? So yeah, here I just did it all the way up at the top level for us. But yeah, almost no Democratic speech. Though there is, like, I think actually these little blue ones are kind of interesting, to be honest, because we often think, oh, it's just totally polarized. And you can see after about, right, here's when the clean power stuff, after that, it's become like literally a non-issue for Democrats, right? But before that, you do see ebbs and flows, and in very specific points in time, right around key sort of climate policy events in the US, right? And I mean, we shouldn't forget that the Democrats controlled the House, the Senate, and the executive during cap and trade. So we had to have had Democrats abandoning ship in order to not get cap and trade policy around here. So they were, if you look at where mostly fossil fuels are good, and they're talking about these particular solutions aren't the right set of solutions. It's delay. Okay, but it does happen. Yeah, it's a Republican problem. Which Republicans? Okay, we went and we had Inhofe at the beginning a little bit. So everybody knows Inhofe, right? The snowball guy? No? Okay, yeah, this is literally him. So we have science-related misinformation claims. This is real misinformation. Okay, these are like, we picked the ones that are actual misinformation, and then delay and energy claims. This dude is out here. Yeah, so he came into Congress. It was snowing in DC, and he brought a snowball in and said, "Look, it's cold. Like climate change, clearly it's snowing in DC right now. It was abnormally cold. And so there's like, if you want it, like the memes are unbelievably good. Like a ham sandwich, like, oh, hunger doesn't exist. Like I got a ham sandwich. Like there's great. So yeah, but you think, okay, that guy's just some wacko, right? Like, oh, this is being taped. You might want to delete that out in case yeah. But he's just somebody that's extreme, right? Maybe he's extreme. And he is, but he's also like the chair of the biggest committee on environmental policy in the Senate. So like, and if we look, right, if we go back into like the more normal people, and we start looking at who these folks are as well, also hold extremely important committee positions, right, when it comes to environmental policy. So these are folks that like have views that might not fit with what we would call the consensus, but are also in a position of power in order to make things happen or make things not happen in this case, okay? So that's that. Yeah, I should probably stop. Haven't gotten to I was gonna even go into stats, I just totally ran out of time. But these are some of the things we've already started this, and I can talk about a little bit about what we're finding. But this is sort of, I would be interested to hear if you guys have other sort of things you think we should be including or controlling for. But these are the sorts of things that we are based on past sort of scholarship. But yeah, that would be helpful. But this is what we have so far. Okay, so we can, yeah, potentially come back to that. And I can roll it back up. Oh yeah, next steps. Okay, so we'll write up the stats. So that's number one. But number two, which we've already kind of started on, is that we're not very interested in floor speeches, actually. Kind of been intimating on that. Like that's just not where policy happens. It sends an important signal and it's useful, Well, really what we want to know about is what's going on in committee. Really what we want to know about is going on in, like, is it the bar when they get out of committee, like where the real stuff is happening, but we have to settle for committee. So my PhD student, Miriam, had, like, part of her dissertation has been going into the whole cap and trade period and annotating all the witnesses in congressional testimonies, and then aligning them on the open secrets sort of class, like basically like it's like businesses and government and this, so you know who they are. So she actually has that, and then all of the Congress people in talking. So you can really see the dynamics about how these people are responding to one another, who's calling who, etc. And so that's basically the next thing we're going to do, is let it loose, let the model loose, which we've already pretty much validated on that. And then another one of my PhD students is also expanding to Twitter, but that to me is less interesting than the Congress stuff, which is that. And I think that's actually it for me. I've kind of bounced around. Yeah. Okay, great.